Hello, dear students. Good morning, all of you. Myself, Pavarya Miss from KJ Somaya College, Kopargaon. In today's lecture, we have to discuss our remaining part of the oxazole molecule, that is a 5-member heterocyclic ring which containing two heteroatoms, that is a oxygen and nitrogen. So, in previous lecture, we have to discuss the synthesis of oxazole molecule, that is a 4 synthesis we have to see in previous lecture. In today's lecture, we have to discuss the chemical reactivity of oxazole molecule, that is a electrophilic substitution reaction or nucleophilic substitution reaction. So first of all, write down the chemical reactivity. First of all, we have to see the electrophilic substitution reaction. Philic substitution reaction of the oxazole molecule. But before after, we have to explain the something of related to the oxazole molecule, that is the important thing. When C5 position of the oxazole molecule which undergoes the electrophilic substitution reaction by using the electron donating group when attached to the oxazole molecule, then C5 position which is preferred for the electrophilic attack. When oxazole is, then we have to see the chemical reactivity of oxazole molecule. Oxazole is more reactive towards electrophilic substitution reaction than thiazole, but so less than imidazole molecule. Remember one thing of oxazole molecule, which is more stable to electrophilic substitution reaction thiazole than thiazole, but so less than imidazole, less than imidazole molecule. Okay. Then nitration and sulfonation reaction of oxazole itself does not undergo, or which is are difficult because of the presence of pyridine type N nitrogen. Why? Uh, Oxazole does not undergoes the nitration and sulfonation reaction because of what? In this oxazole molecule, presence of the N type pyridine type N nitrogen. Here presence of the pyridine type N nitrogen, so it difficult to nitration and sulfonation reaction. Okay, remember this thing very well. Then next we have to discuss the electrophilic substitution reaction. So it also undergoes the disulfide type reaction. For example, we have to take here disulfide type reaction. Then for example, we have to take here oxazole. Oxazole reacts with the alkyne. Reacts with alkyne R dash again. For example, we have to take here C triple bond C CO CS3 CO CS3. So it does not behave like a furan type disulfide reaction because of here presence of the oxazole molecule, here presence of the two heteroatoms. So here does not react like a furan. Okay, why? Because of here formation of the adduct type intermediate or a product. Then we have to get in, we have to take we have to form here, for example, adduct formation. Then we have to use the dehydration. So formation of the pyridine type ring or substituted pyridine ring, when we have to insert here minus RCN, then formation of the pyrrole, sorry, furan type molecule. Okay, 5 member and 6 member ring. Okay, so this is also the Dicellular type reaction. When this undergoes, then this take part, and then this, in this way, bond forming and making or breaking takes place here. So formation of the here in this type molecule, see here. Okay, this triple bond convert into the double bond, this COOCH3 as it is, COOCH3 as it is. Adduct formation means 6 member ring which attached to this here, again here attached to the R, here attached to the R. Okay, but here we have to see the R, again here R dash, R dash. Then this R dash incoming in this adduct formation, in this R dash and in this R dash. So cyclization or 2 plus 2 cyclization reaction takes place like a dicellular reaction in this way, and formation of this adduct. Okay, this is the important. This adduct can be formed. Okay, so simply here we have to explain you the by using minus dehydration or minus H2O, formation of here double bond converting into the triple bond. Then this double bond, one double bond can be as it is. So formation of the dehydration takes place pyridine type molecule. Okay, so this is numbering. Then we have to attach the CS substituent as it is COOCH3. Then remaining part, that is your alkyl group. Okay, this is R dash, this is R, and this is R. So here is minus H2 can be deeper. Okay, so R dash remaining here. So this R attached to this nitrogen, then then uh, migrate or shift to the another carbon. Then see here the formation of the pyridine type reaction when we have to dehydration takes place when we have to minus RCN, then formation of the furan molecule. Okay, here we have to take the minus RCN, formation of the furan type, that is this is your COCH3, COCH3, then R dash and R dash remaining in this way. This is the furan, this is the pyridine ring by using the dicellular reaction. In next we have to see the nucleophilic substitution reaction. In nucleophilic substitution reaction we have to discuss here discuss by the or increment or the increasing the numbering of the electrophilic substitution reaction, that is a C4 C2 greater than C4 and then C5. This is depend on the halogen shift. Okay, or it depends on the halogen displacement of in oxazole molecule. So we have to take here the some example, that is a nucleophilic substitution reaction. First of all we have to take here oxazole. So this oxazole first of all reacts with the, suppose here we have to take substituent CH3 C6H5 C6H5 reacts with ammonia in presence of 180 degrees Celsius. This mechanism which is the important, which is asked in the exam. Then formation of the here this compound. Okay, so how this possibility can be formed? So see here the mechanism. Okay, this is the oxazole molecule CS3 C6H5 C6H5. So it reacts with ammonia, temperature condition 180 degrees Celsius. Then this nucleophilic substitution reaction can be takes place. So this lone pair of nitrogen attack on this carbon. At that time this carbon oxygen can be break and shifts on this carbon. So this bond shifts on this carbon again. Okay, lone pair of nitrogen attack on this carbon. So this carbon oxygen bond shifts on this carbon. So this bond shifts on this carbon again, formation of the, see here formation of the carbonyl, and here addition of NH2 CH3 as it is, here nitrogen as it is, again this substituent, that is C6H5, but this carbon carries negative charge because of this double bond shifts on this carbon. Here formation of the carbon oxygen double bond, and this C6H5 as it is, again this double bond as it is. Then again in next step, here presence of the carbonyl, again we have to take ammonia in presence of 180 degrees Celsius high temperature condition. Again this lone pair of nitrogen attack on this carbonyl carbon. At that time carbonyl convert into the OH, and at that time this NH reacts this carbon, then 1H can be stabilized by this negative charge. Okay, so formation of here C N, here addition of NH2, again here OH C6H5, this is C6H5 as it is, this negative charge stabilized by one hydrogen of the ammonia. Again here NH2 CH3, we have to write here NH2. Okay, this double bond as it is. Simply here see here this intermediate can be formed. Again here presence of the one hydrogen, so this hydrogen used for the double bond formation. At that time this water molecule can be depart here, dehydration takes place in this step. So formation of nitrogen as it is, here NH2 here CH3 as it is, double bond, here formation of the double bond C6H5 as it is. So see here formation of the NH2 two NH2 can be here obtained. Both NH2 can occupy the or can presence of the lone pair of, so this lone pair of nitrogen attack on this carbon, so minus NH3 can be depart. So in this reaction, okay, see here any one amine group we have to take here. So presence of the already lone pair of electrons, so this lone pair of electron attack on this any one carbon, so one ammonia can be depart here. Okay, minus NH3 can be depart here. Okay, in the form of ammonia. So formation of the here nitrogen, here again NH double bond as it is, double bond as it is, so C6H5 C6H5. So here formation of the NH, one H used for the double bond formation, and ammonia can be depart here. So formation of the your final molecule, that is a by using two nitrogen atom, that is a oxazole or pyrazole. So it depends on the nature of your imidazole molecule. So it form the imidazole molecule. Okay, this is the oxazole and this is the imidazole molecule. This CH3 as it is, this is the imidazole molecule. Okay, so this is related to the nucleophilic substitution reaction of oxazole molecule. Then we have to see the reaction with oxidizing and reducing agent. Then next one, this is the important synthesis. Oxidizing agent we have to use in oxazole molecule. So first of all, oxazole ring is not stable to oxidizing agent or oxidizing agent we have to use. It is does not stable for the oxidizing agent. So oxazole is normally stable to action of hydrogen peroxide. Okay, we have to use the potassium permanganate or osmium tetroxide. When oxazole molecule which is does not stable, when we have to use the uh, hydrogen peroxide, that is a S2O2, which is presence in the OHAC, then formation of the oxide type product or n pyridine type oxide. When we have to take here oxazole, which is substituted the pyridine ring, then when we have to explain you oxazole, which is not stable to oxidizing agent, when which is stable to the hydrogen peroxide reagent in presence of OAC, HOAC, then formation of the oxide N oxide type product. So here we have to take this oxazole 4 or 2, sorry, oxazole 2 pyridine. So formation of the in presence of S2O2 in OAC, HOAC. So formation of N oxide type compound like in this way. So this is the reaction of oxidizing agent. Here formation of the in this type oxidizing agent, this N oxide can be formed here. For example, we have to take the N from this side, here N, then in this way we have to only shift the position of nitrogen, then here formation of the in this way simply we have to take nitrogen position here. So oxide and this nitrogen carries positive charge. So here formation of the oxide, N oxide in place of S2O2, when oxazole can be reacts with the reducing agent. Next reaction with reducing agent. So in this reducing agent, oxazole can stable the reducing agent type reaction, or which is stable for the by using the reducing agent. When oxazole stable towards the variety of reducing agent, when oxazole reacts with the lithium aluminum hydroxide, formation of, for example, this is the oxazole, then this oxazole, which is the substituted by phenyl ring C6H5 reacts with reducing agent, variety of reducing agent, that is we have to take here lithium aluminum hydride in presence of THF. Okay, so formation of like in this way ring opening takes place here, CS2NH. For example, this is the CS2NH, here again CS2 C6H5, here CHOH C6H5. This product can be obtained, that is a ring opening reaction takes place. So this is all about the chemical reactivity of oxazole molecule. First of all, we have to discuss the electrophilic substitution reaction, then nucleophilic substitution reaction, then oxidizing and reducing agent. Okay, so this oxazole molecule can be finished here. So remaining molecule we have to discuss in our next lecture. Thank you very much.